Hello everyone, today let's see class 12 chapter 5 continuity and differentiability, exercise 5.2 question number 1, 2 and 3, 4. Okay, so before all, first we'll see the important formulas that are based on the problem. Okay, so first is differentiation of x power n. Differentiation of x power n is n into x power n minus 1. Differentiation of x is 1. So here n is 1. So and x power 1 is equal to 1 into x power 1 minus 1, 1 into x power 0, x power anything power 0 is 1, so 1 into 1 is 1. Okay, so here differentiation of root x is 1 by 2 root x. So here n is 1 by 2, root we can write as 1 by 2. Okay, so x power 1 by 2 is equal to 1 by 2 into x power 1 by 2 minus 1. So half into half minus 1 is x power minus half, right? So this minus half can be written in the denominator as 1 by 2 root x. Okay, and next one is d by dx of 1 by x. Okay, differentiation of 1 by x is here x is actually minus 1, right? So it is x power minus 1. So n is actually minus 1, sorry. N is equal to minus 1. So x power minus 1 is equal to minus 1 into x power minus 1 minus 1. Minus 1 and minus 1 is minus 2. So minus 1 by x power 2. And differentiation of constant is actually 0 and differentiation of ex is ex itself. Differentiation of ax is equal to log ax log a. Differentiation of log x is equal to 1 by x. Okay. Now we'll see is differentiation of trigonometric functions. Differentiation of sin x is cos x. Differentiation of cos x is minus sin x. And tan x is secant square x. Cosecant x is minus cosecant into cot x. Secant x is secant x into tan x, and cot x is minus cosecant square x. We can see wherever if it is cos, it is minus sine, cosecant minus cosecant cot x, cot minus cosecant square x. Okay, we can just remember if a trigonometric function which is starting with c, so its differentiation will give a minus. Okay, and next is the rule. Some of the rules we'll see. First is the constant rule. So first is the constant rule. D by dx of constant into some value will get constant into differentiation of that u. Okay, and addition, this u can be trigonometric, polynomial, exponential. Okay, and addition and subtraction rule. D by dx of u plus or minus v is equal to. So here differentiation rule will be so first it will differentiate the first function and next is the differentiation of other function. Okay, so whatever the symbol plus or minus, it will just add or subtract. Next one is the product rule. Differentiation of u and v is, first we have to keep one function as it is. If it is we'll say if we say v du by dx plus u dv by dx is also same. Okay, first any one of the function we have to keep as it is and differentiate the other function, plus any the remaining function we have to keep as it is and we have to differentiate the function which we have taken as it is before. Okay, and next one is quotient rule. D by dx of u by v is equal to v du by dx. So denominator first we have to keep as it is and next we have to differentiate the numerator. Here we have to be very careful because here it is a negative sign. Okay, first we have to differentiate the numerator. Denominator we have to keep as it is, minus differentiation of denominator into the numerator, whatever is there as it is we have to take, divided by the square of the denominator. Okay, let's start with the problem. First problem we are going to deal with is sine of x square plus 5. Okay, so here we have to follow chain rule. If we have to follow chain rule, we have to remember that if y is a, we have to differentiate the function f of g of x. So according to chain rule, first we have to differentiate the outer function and we have to write the inner function as it is into, we have to just cross that function or else we just have to neglect the function whichever we have differentiated, and next the inner function we have to differentiate. Okay, so here I'll say this is the outer function and this is the inner function. Outer function is sine and inner function is polynomial. So first we have to differentiate sine x square plus 5, right? So differentiate sine. Differentiation of sine is d by dx. D by dx of sine x is equal to cos x we know. So cos, right? In the place of x, cos x, in the place of x there is x square plus 5. We have to write as it is into d by dx of the inner function x square plus 5. Okay. So cos x square plus 5 into, so x power 2. X power 2, 2 into x power 2 minus 1. 2x. Okay. 2x plus 5 is actually a constant. Differentiation of constant is 0. So therefore differentiation of sin x square plus 5 is cos x square plus 5 into 2x. Okay. Now let's see the second question. Differentiate cos into sin x. Okay. Composite of two trigonometric functions. This is the outer function and this is the inner function. Differentiation of cos is minus sine. In the place of x, sin x is there. Minus sine of sin x into d by dx of sin x. Okay. Differentiation of sin x is cos x. So minus sine of sin x into cos x. Okay. Now let's see the third question. So differentiation of sine of ax plus b, right? Here sine is the outer function and ax plus b is the inner function. First we have to differentiate sine. Differentiation of sine is cos, in the place of x, ax plus b. Okay, into d by dx of ax plus b. Okay, here a and b are some constant, and so cos of ax plus b. So we have learnt at the beginning d by dx of ku is, k we will keep as it is and u we will differentiate. So here a is a constant, so a will keep as it is, and so we have to differentiate x. So we have seen differentiation of x is actually 1. Okay, differentiation of a constant is 0. So answer is a cos ax plus b. Okay, now let's see fourth question. Fourth question is differentiate secant x of tan root x. Here we can see three functions. Okay, trigonometric outer function f, g and h. Okay, here first we'll differentiate secant. Next is tan. Next is root x. Okay, so differentiation of secant we have seen. Differentiation of secant is secant x into tan x, right? So secant, in the place of x, secant of tan root x into tan of tan root x. Here we can you may get a doubt like sine into sin x. Why can't we write as sine square x? But that's not at all possible. Okay, this is a major mistake that appears, but we have to avoid that. Differentiation only this much. Okay, multiplication, it is a composition. Okay, so secant of tan x, tan root x into tan of tan root x, we have differentiated secant into d by dx of tan root x we have to differentiate. Okay, and so secant of tan root x into tan of tan root x into tan x. Differentiation of tan x is secant square root x. In the place of x, there's x, root x. Okay. So next we have to differentiate that's in a function. We have to differentiate the g, so we have to differentiate h. Okay. So now secant of tan root x into tan of tan root x into secant square root x into, we have seen differentiation of root x is 1 by 2 root x. Okay, this is the answer for the fourth one. Thank you for watching. For more updates, do subscribe and press on the bell icon so that you will get the notifications whenever I upload a new videos. If you have any doubt, to comment in the comment section. It will be more easier for me to give explanation on those particular questions. Thank you.